Good morning, everyone. Today we'll discuss about the basic concepts of fluid mechanics. So, in this presentation, I am going to explain our introduction about the fluid mechanics and what are the fluid properties, types of fluid flows, and advantages of fluid mechanics in real life where the fluid mechanics is applicable. So, before going for the fluid mechanics introduction, we will study about the basic concept. As we know that intermolecular bonds are strongest in solids and the weakest in gases, and the matter is divided into three categories. One is the solid, liquid, and the gases, and another extreme case is nothing but a plasma state. Depending upon the intermolecular bonding nature, we can classify the matter into whether it is a solid or a liquid or a gaseous stage. In solid, the molecules are tightly bonded, and the liquid, as compared to the solid, the molecules are loosely bonded, and in gases, the molecules are freely bonded. Okay, this is the structure of a solid, liquid, and a gaseous stages. And another pictorial form is nothing but the liquid and gaseous stage here. You can see in this slide. Now we will go for the what do you mean by fluid? A substance which is capable of deforming continuously. That substance we can call it as a fluid, or the combination of a liquid and the gases we can call it as a fluid. Okay. In another form also we can define fluid is nothing but the substance which deform continuously under the influence of a shear stress. We can call that substance as a fluid here. In solid, stress is proportional to the strain, but in fluid, the stress is proportional to the strain rate. This is the main difference between the solid and the fluid. I repeat, in solid, stress is proportional to the strain, and in case of a fluid, stress is directly proportional to the strain rate. Okay, this is the difference between the fluid and the solid. The classification of fluid mechanics is divided into three categories. As we know that fluid mechanics is nothing but it is a branch of science which deals with the behavior of the fluid in rest as well as in motion. And this fluid mechanics is classified into three branches. One is the fluid static and fluid kinematics and the fluid dynamics. Fluid static is nothing but a study of fluid which is under rest is called as fluid static. And the fluid kinematic is nothing but a study of fluid which is in motion where the pressure forces are not considered. And the fluid dynamics is nothing but a study of fluid, most fluid particles which are in motion where the pressure force is also considered. And next one is nothing but has fluid static. Static indicates at rest. In the sense, the behavior of the fluid particles you are studying in the case of rest positions. Fluid static, the study of fluid at rest is on the of fluid static, and this fluid dynamics again it is classified into two branches. One is the aerodynamics and the hydrodynamics. This mechanics it is the oldest physical science that deals with the both stationary and the moving bodies under the influence of forces. And dynamics it is a branch that deals with the bodies in motion. Okay. And another definition is nothing but a stress. Stress is nothing but a force per unit area is known as a stress. And normal, there are two kinds of stresses acting on a body. One is the normal stress and the shear stress. Normal stress is nothing but the normal component of a force acting on a surface per unit area. That is known as a normal stress. You can see in the diagram here. This is the normal stress, and the shear stress is nothing but a tangential component of force acting on a surface per unit area. This is nothing but a tangential stress or a shear stress. Zero shear stress in the sense the fluid which is at rest is experienced by the zero stress tensor. Some background about the fluid mechanics. The study of fluid mechanics goes back at least to the days of ancient Greeks when Archimedes and he investigated the fluid statics and the buoyancy. He was formulated this famous principle as Archimedean principle, which was published in his work on floating bodies, generally considered to be the first major work of the fluid mechanics. The rapid advantages in fluid mechanics began with the Leonardo and Vinci observation and the experimentation is done by him. And Evangelist and tourism, he has investigated the barometer. Isaac Newton, he has investigated the viscosity. And the Blasius or the Pascal, He has introduced about the hydrostatics and formulated the Pascal's law, and continued by the Daniel Bernoulli with the introduction of mathematical fluid dynamics in hydrodynamics. So many mathematicians and physicians worked on this fluid mechanics and investigated many instruments on this. Then we'll go for the properties of a fluid. So basically, we will study about the uh, fluid properties as density, specific weight, specific gravity, viscosity, specific volume, and the vapor pressure. These are the major properties which we will do. Other than these, also there are many properties of the fluid we can see. And first one is we'll study about the density. Density varies with the temperature and the pressure and the soluble compounds. As the density definition is known by, density is nothing but mass by volume, and mathematically it is known as density is indicated by rho. Rho equals to mass by volume, and here mass denoted by the density of the fluid, and the symbol rho indicate for the density, m is indicated for the mass. And the stresses is nothing but a force per unit area is nothing but a stress. It is a, if the normal force is active with the extra with respect to the area, then we will call that as a stress. This stresses is divided into two components, normal stress and the shear stress. Normal stress in liquids are generally compressor, and they are referred by a scalar quantity, and it is known as a pressure. Viscosity, it is a major property of a fluid. Viscosity is nothing but a stickiness property or the internal resistance between the two fluid layers. It is ability of the fluid to flow freely, and mathematically it is a property of a fluid that relates the applied shear stress to the rate of deformation. Viscosity usually varies with the temperature. Okay, and the thermal conductivity, it is the ability of the fluid to transfer the heat through the system. Mathematically, it is similar to the viscosity. And the another property is the bulk modulus or of elastic and compressibility. Compressibility is the change in density due to the change in normal pressure. The reciprocal of compressibility is known as the bulk modulus of elasticity. Liquid has very high value of elastic properties, elasticity as compared to the gases. Okay. Coefficient of thermal expansion. Thermal expansion is the change in fluid density due to the change in temperature. Liquid in general has less sensitive to the thermal expansion than the gases. And so now we'll see the application of fluid mechanics. There are many areas in our day-to-day life where we can see the application of fluid mechanics, such as the design of wide range of hydraulic structures like dams, canals, wires, etc., and pump, turbine, etc., and design of complex network pumping and a pipeline for transporting liquids flow of water through pipes and its distributions to several lines. Design and analysis of gas turbines and rocket engines and aircraft, they are manufactured on the basis of fluid mechanics concept. Power generation from the hydraulic stream and gas turbines, method and devices for measurement of pressure and velocity of the fluid motions, they are constructed on the basis of fluid mechanics concept. And a few applications I'm showing here. Here the artificial heart is manufactured and it is stored on the basis of fluid mechanics principle. And natural flow and weather forecasting is done on the basis of aerodynamics. And here power plant energy is generated by the application of fluid mechanics. And the construction of a boat and the shape is designed on the basis of fluid mechanics. Aircraft and the spacecraft is manufactured, shape design and the fuel efficiency is measured on the basis of fluid mechanics itself. And the human body, the stethoscope, the manufacture of design of this stethoscope is on the basis of fluid mechanics, and the design of this car is also on the basis of the fluid mechanics. Wind turbines in order to generate the electricity or the energy, and a pipeline system and industrial applications of a design of this manufacturing these designs, they are depend upon the fluid mechanics concepts. In day-to-day life, I can say that we are using the toothpaste, shampoo, soap, conditioner. So whatever the materials which we are using in our day-to-day life, they are nothing but a fluid itself. Now we will classify how many types of fluids are there. So for that, we have to study the types of fluids. Basically, there are 5 types of fluids: ideal fluid, real fluid, Newtonian fluid, non-Newtonian fluid, and the ideal plastic fluid. Ideal fluid is nothing but a fluid which has zero viscosity, that is known as an ideal fluid. For example, air and water, they are the ideal fluids. Real fluid in the sense the fluid which possesses some kind of viscosity, those are nothing but a real fluid. For example, honey, toothpaste, oil, etc. We can give the example. In general, all fluids they are the real fluid itself, because every fluid is having its own viscosity. Only the percentage of viscosity will be different. Newtonian fluid in the sense a real fluid in which the stress is directly proportional to the rate of shear strain. That is known as a Newtonian fluid. And non-Newtonian fluid is nothing but it is opposite to the Newtonian fluid. A real fluid in which shear stress is not proportional to the rate of shear strain, then you can call it as a non-Newtonian fluid. Ideal plastic fluid in the sense a fluid in which shear stress is more than the yield value of the shear stress and it is proportional to the rate of shear strain. It is known as a ideal plastic fluid. Now we will go for the classification of a fluid flows. Depending upon the flow nature, the fluid is classified into various types. First, we will say about the viscous with inviscous flow. Viscous flow in the sense the flow in which the frictional effect are significant is known as a viscous flow. Frictional force in the sense stickiness property. The flow in which the stickiness property is more than that kind of a flow is known as a viscous flow. In viscous flow in the sense in many flows of practical interest there are the regions where viscous forces are negligibly smaller. Okay, that kind of regions we can call it an inviscid flow. In this region you can see the middle part is nothing but a viscous flow region, and neighbor to this viscous flow region, this is an inviscid region. Internal versus external flow. External flow in the sense the flow of an unbounded fluid over a surface such as a plate, a wire, or a pipe. Internal flow in the sense the flow in a pipe or duct if the fluid is completely bounded by a solid surface. That kind of a flow we can call it as a internal flow. Water flow in a pipe is a internal flow, and air flow over a ball is a external flow. Next classification is compressible versus incompressible flow. Incompressible flow in the sense if the fluid is flowing in which the density is maintained as constant, in that case that kind of a flow we can call it as the incompressible flow. Compressible flow in the sense if the fluid is flowing with a variation in the density, then we can call that kind of a flow as a compressible flow. Analyzing the rocket, spacecraft, and other systems that involves high-speed gas flows, the flow speed is often expressed by a Mach number. Mach number is a non-dimensional number. Depending upon this Mach number, we can classify again which kind of a flow is flowing. Okay, this is the range of a Mach number. If the Mach number is 1, then it can call that flow as a sonic flow. This is nothing but a periodic wave nature form. Mach number it is less than 1, then it is a subsonic flow. If it is greater than 1, it is supersonic flow. If it is highly greater than 1, it is known as a hypersonic flow. Next classification is laminar flow versus turbulent flow. Laminar, the word itself indicates that uniform. If the fluid flowing in an orderly manner, then that kind of a flow we can call it as a laminar flow. Turbulent flow in the sense if the fluid flows moves in a zigzag manner, then that kind of a flow we can call it as a turbulent flow. In between to laminar to turbulent, the phase is known as a transitional flow. In the sense, the flow that alternates between the being in laminar to turbulent, it will take some region, that is small region is known as a transitional region. Natural versus forced flow. Forced flow is the thing, but the fluid is flowing due to some external forces. That kind of a flow is known as a forced flow. Natural flow in the sense the fluid motion is due to the natural means such as the buoyancy effect, which manifests itself as a rise of warmer, and the fluid falls under the cooler position. In the sense, it moves from hotter to cooler due to the natural phenomena. Steady versus unsteady fluid. The fluid flow which is independent of time period, it is called a steady flow. If it is depends upon the time period, then it is known as a unsteady flow. In the diagram, you can see the first picture, it shows about the unsteady flow, and this is a steady flow. So overall summary in this presentation, what we have studied, we have seen some brief history of fluid mechanics and the basic concept of fluid mechanics and the classification of fluid flows and viscous versus inviscous, internal versus external, compressible versus incompressible, laminar versus turbulent, and natural versus forced flow, steady versus unsteady flow, and the application of fluid mechanics. Thank you.